My name is Nuno Fachada. I'm a teacher and a researcher at Lusófona University in Lisbon, Portugal, and this presentation will be about the top-down design of a computer science curriculum for computer games BA. According to Matthias and Whitehead, there are three types of undergraduate degrees in computer games. The first type are technology-oriented degrees, which are typically Bachelor of Science. The second type are art-oriented degrees, usually Bachelor of Arts. The third type are evenly interdisciplinary degrees, which can be Bachelor of Science or Bachelor of Arts, depending on the balance curriculum designers wish to offer. They are, according to the same authors, the most challenging to put in practice. The Bachelor in Video Games at Lusófona University is an evenly interdisciplinary BA. It has a duration of 3 years or 6 semesters. The student profile in the Bachelor in Video Games is as follows. Students come from various high school areas of study, which means that non-technology students are bound to struggle with computer science course units. We also have some gamer students. However, playing games does not necessarily reflect on the enjoyment of actually making them. Having this into account, we designed the curriculum using a top-down, holistic, integrated approach, where game development requirements such as the choice of game engine or what type of games should be developed inform the supporting topics and computer science materials to be offered to students. Supporting topics can be divided into large parts: advanced computer science topics and introductory topics. The former, such as artificial intelligence, computer graphics, databases, should be chosen based on what type of games should be developed. The introductory topics should be chosen mainly to support what is offered at the advanced and game development level. Lusófona's Bachelor in Video Games is organized as follows in the first 2 years. In the second, third, and fourth semester, students are offered game development courses. The game engine of choice is the Unity game engine, which uses C# as its scripting language. For the type of games to be developed, artificial intelligence was deemed the most essential advanced computer science topic. Supporting this, there is in the third semester an advanced object-oriented programming course, in which game design patterns are studied. This allows for a better understanding of object-oriented programming. However, an introduction to object-oriented programming general ideas is given in the second semester of the first year. This, of course, is given using the C# language. In the first semester, 2 distinct programming courses are proposed to students. In the first one, Introduction to Computing, students learn how to program using the C language. This is done using a low-level approach where the students gain some notion of computer architecture and how to allocate memory and free it afterwards. The second course, Programming Fundamentals, is given using the Python language. Programming Fundamentals in Python allows students to quickly prototype programs and games. The idea here is that students can develop their algorithmical thinking faster without being constrained by the low-level approach of the C language. Finally, 2 Math and Physics for Games courses are offered in the first and second semester. These courses mostly use the Python language, although an attempt to transition to C# and Unity is made at the end of the second semester. The new top-down curriculum was introduced in 2017-18 academic year and moving forward year by year since then. As such, 2019-20 academic year finalists are the first under the new curriculum. How can we evaluate how students fare under the new curriculum? The approach we used was to compare grades and games in second-year game development courses. As such, we analyzed game development courses from 2016-17 to 2018-19 academic years. These courses had the same teacher, the same evaluation criteria, allowing for a fair comparison. Second-year students in the 2018-19 academic year were the first to attend the second-year game development courses under the new curriculum. Consequently, we are interested in comparing the 2018-19 academic year with the 2 previous years. The courses we used for this comparison are GIDI 2 Game Development 2 in the third semester and GIDI 3 Game Development 3 in the fourth semester, both second-year courses. Let's take a look at the grades first. Grades are given in a 0 to 20 scale. In the GT2 course unit, we can observe that in the 2018-19 academic year, average grades are notably higher than in the two previous years. In the GD3 course unit, the situation is similar. Under the new top-down curriculum, grades are clearly centered around higher values than in the two previous years. These results show not only an increase in the number of high-quality projects, but also an increase in the average quality of these projects. Additionally, we observed improvements in the students' technical abilities, and also greater experimenting and adaptation capability. Finally, technical limitations of the students had much less impact in the final results. We now analyze the impact the new curriculum had on the games themselves. We start by looking at Capture, one of the best games in the 2017-18 academic year, which had a grade of 19 in 20 possible points in the GE2 course unit. Already under the new curriculum, Geiger Sticking was a standout game in the GD2 course unit, in which the player finds himself in the Chernobyl power plant after the meltdown. In the GD3 course unit of the same year, Heróis do Mar, in English Heroes of the Sea, is a brawler game in which the heroes are represented by Portuguese historical figures. It had a grade of 17 in 20 possible points. Also a standout game in the same semester, in the GD3 course unit, is Once Upon an Island. It's a puzzle platformer. It had a grade of 17 in 20 possible points in the 18-19 academic year. In this presentation, we discussed the top-down computer science curriculum for Computer Games BA. We discussed the impact of this curriculum on a practical implementation. Results were assessed through the game development course units, namely through their grades and the quality of the produced games. Results show that the top-down curriculum led to an improvement both quantitatively and qualitatively in the grades in the games, and we also observed increased student preparation and student capabilities. For more information, please check our paper and the proceedings. Please feel free to ask any questions in the forums. Thank you very much and see you next time.